What's the difference between polar and nonpolar covalent bonds? In a nonpolar covalent bond, the electrons are shared equally. So electrons aren't going to favor one atom over the other. They are shared equally. In a polar covalent bond, electrons are shared unequally between the atoms. The electrons that are being shared are going to move closer to one atom over the other. They are shared unequally. This is determined by the electronegativity of the atoms forming the bond. So you're probably wondering, right, what is electronegativity? Electronegativity is the ability of an atom to attract shared electrons. So an atom with higher electronegativity is more likely to pull the shared electrons in a covalent bond closer to it. When the electronegativity difference between the two atoms in a covalent bond is less than 0.5, when it is less than 0.5, it is a nonpolar covalent bond. When the electronegativity difference is between 0.5 and 2.1, the bond is going to be a polar covalent bond. First, I'll give an example of a nonpolar covalent bond, F2. F2 is composed of two fluorine atoms, and since both atoms are the element fluorine, both have the same electronegativity, and therefore the bond is nonpolar. So let's say these are the two fluorine atoms, and these are their electrons. They each have 7 valence electrons. These two fluorine atoms are going to be sharing these two electrons, this one and this one, equally in a covalent bond. Because their electronegativities are the same, the electrons aren't going to move closer to one fluorine or the other. For the example of a polar covalent bond, I will use the example of HCl, hydrochloric acid. So let's say this is hydrogen with its one valence electron. Remember, hydrogen only needs 2 valence electrons for a full valence shell. And let's say this is chlorine with its 7 valence electrons. If we go to our reference table, this is the New York Regents reference table for chemistry, we can see that hydrogen's electronegativity is 2.2, while chlorine's electronegativity is 3.2. So this means that there is a difference of 1 electronegativity between hydrogen and chlorine. So that means it is a polar covalent bond. Because chlorine has the higher electronegativity, 3.2, the electrons are going to be closer to chlorine, right? Remember, electronegativity is the ability of an atom to attract shared electrons. This is going to result in chlorine and hydrogen both having partial charges. Chlorine will have a negative partial charge because the electrons are going to be going closer to chlorine. Hydrogen is going to be losing negative charge, meaning it will be gaining a partial positive charge. So we can denote this by a symbol called lowercase delta, which looks like this, and we can put the positive or negative symbol next to it. So we'll put negative for chlorine and positive for hydrogen. So this is essentially saying that this is a polar covalent bond where hydrogen is partially positive charged and chlorine is partially negative charged. Lastly, you can remember the difference between nonpolar and polar bonds through the word poles. In a polar bond, there are 2 poles, the partial negative atom and the partial positive atom, hence the name, right? So here we would have chlorine as our negative pole and hydrogen as our positive pole. In a nonpolar bond, there are no poles. Both atoms are sharing the electrons equally. There is no negative or positive pole in F2. It is just fluorine. That's all for polar and nonpolar covalent bonds. If you were confused as to what a covalent bond is or what valence electrons are, I will link a playlist that contains videos explaining these topics.